So hello everyone. Let's see how to trace a recursion. So we know that recursion, what happens is a function calls itself. So the most important data structure when it comes to recursion is its stack is used. So here I assume that you know how an activation record is created in C. So these all things. If you don't know, I'll make videos on them. Please mention it in the comment section. So now let's see this. This is a function a of n. So this is a recursive function. So let's say there is a function main, okay, somewhere, and inside this a of let's see, let's take n equal to let's take n equal to 3. So let's say a of 3 is called. So there will be lines here, some lines of codes here, there will be some lines of code. So now this will be called, okay. So now a of 3 is called. So what happens is when a function is called, so in C, when a function is called, an activation record is created in the stack. So now main is a function, right? So an activation record will be created. So it will have its all local variables. This all information will be there in the stack. So now a of 3 is also a function, right? So again, one more activation record is created here. So this is for a of 3, right? So it will have its local variable. Now n, we have called it with the value 3. So for convenience, let's what do is let's name number these line. Okay, 1, 2, 3, 4, 5. So line number 1, 2, 3, 4, 5. It will be easy for us to refer while explanation and also while understanding. So now what happened is a of 3 is called right here. So a of 3 is called with the value n equal to 3. So what happens in the code here, it checks. So n is equal to 3, right? So 3 is greater than 0. So it is correct. So it will enter here. So now percentage d n minus 1 is being printed. So what is 3 minus 1? 2. 2 will be printed. So let's have whatever will be printed. Let's have it here. Prints. So let's now 2 is printed, right? So 2 is printed. So now this is done. Now what happens is again a of n minus 1 is called. So a of 2 will be called. So now this is a function. So what happens is here in the stack, one more activation record will be created for a of 2. So now one thing about is this is now here before means before going to a of 2, what this function will do is it will remember after the recursion is done what is the next instruction or the line of code that should be executed. So now this is line 4, right? A of 2. So now here a of 3, it completes at line 5. So here in the activation record, what it does is it will remember I have to come back and execute line number 5. So this information is stored in something known as instruction pointer. So instruction pointer remembers what is the next um, line of code that should be executed once the recursion ends. So once recursion ends, okay. So it should remember that. So it is remembering I should come back and execute line 5. Now a of 2. So a of 2 is called. So what happens is we come again here. Now again 2 is greater than 0, right? So it enters here. So now 2 minus 1. 2 minus 1. What is 2 minus 1? 1. 1 will be printed now. So now next a of 1 is called, right? A of 1. So what happens is here one more activation record is created for a of 1. So before doing this, it will remember now again this a of 2 will remember that I have to come back and execute line number 5. So it will remember it. So now again a of 1 is called. Again we get into the function recursive call right here. So again, so this is here. This becomes yeah. So this becomes a of 1. So it enters here 1 is greater than 0. 1 is greater than 0, right? It's true. So it enters here. What is 1 minus 1? 0, right? 1 minus 1 is 0. N minus 1 we are printing. So 2, 1, 0 now. 2, 1, 2, 1 was printed previously. Now 0 is printed. Now next. Again 1 minus 1 is 0. So now a of 0 is called. So now again this a of 1 also will remember that. Next I have to come back and execute line number 5. It will remember this. So now a of 0 is called. So when a of 0 is called, one more activation record is created. Yeah. So this is one more activation record. So again, now here uh, when we when we come here, a of 0 is called. So now 0 is not greater than 0. If it was equal to 0, then it would have entered. But now strictly greater than it's given, so it will not enter this, so this terminates here. So this a of 0 is not, so this function just returns there. So this activation, so a of 0 is not done, so this is popped off. So now this recursion has end. So now, but it has not yet completed. It has remembered that I need to execute these lines, right? Phi everywhere. So now what happens in the stack? So top one, now this will be the top. So here it knows that I have to come and execute line number 5, but there is no means line number 5 is nothing but here. Now here it's nothing but the end. So right, so it comes, executes, and this activation record is popped off. Similarly, now again it comes to a of 2. Here also it remembers that I have to execute line number 5. Again same, right? Line number 5, it's just the end of the function, so just this is popped off. So again similarly here it's popped. Then now it comes to main. So main here, whatever this now a of 3 was called here, right? This is it. So some lines of codes are there. It may be print whatever. So it executes and finishes. So now at the end we printed 210. So this is how we trace a recursive program. We'll do more examples so that we'll understand how to trace recursion. So it will be easy to solve the coding questions in placement, etc. I hope you liked it. If there is any basics required, like how this um, how pointers work, how these activation records are created, more details are required, please mention it in the comment section. I'll make videos on that. So next video, let's see one more example so that this tracing of recursion is understood clearly. So thank you.